This is Mr. Hayashi with Chapter 4, Transformations, and then starting on 4.1, Translations. So you went over transformations probably a couple of years ago with your different types of transformations, such as a translation, otherwise known as a glide, a rotation or a turn, reflection, and then a dilation as well. So starting with translations, you can translate a point, you can translate a segment, you can translate a polygon. One way to show a translation is using a vector. So a vector has two parts, magnitude and direction. And then so to express a vector looks like a ray. I'm specifically using graph paper right now so you could see the parts of the vector. The magnitude is the length of the vector. Even though it looks like a ray, it doesn't go forever in one direction. And then the direction is which way you go. So for this, the end point is really the initial or starting point. And then the end of the arrow or the end of the vector is the terminal point. And then with this vector or any other vector, especially if it's graphed on a piece of graph paper, there's two parts to it right here. This is the horizontal component. And then this would be the vertical component. The horizontal and vertical component make up a right angle. And in this case, the horizontal component is 3 units. The vertical component is 2 units because it's 3 to the right and then 2 spaces up. So one way that I could express this vector is what's known as component form. That's component form of a vector. So component form of a vector looks like this. You have, or you use brackets. So instead of like parentheses, it kind of looks like a inequality, but it's different than an ordered pair for sure, even though, as you'll see, it's similar to an ordered pair. So the first number or the first element in the component form is the horizontal component. It's just your x direction. And then the second number is the y direction or the vertical component. So in this case, for this specific vector, again, it's 3 units to the right. So 3 is the horizontal component, and then 2 units up is the vertical component. So this is what's known as component form, specifically of a vector. Okay, be able to go from one way to another. If you're given the vector in terms of a diagram or on a graph, be able to write the component form, or the other way around. Be able to go from component form to drawing the vector. For example, if I have a vector and component form is -1, 4, and I wanted to put that vector in a coordinate plane or in a diagram on a piece of graph paper. So -1, here's my initial point. It's like the origin on the coordinate plane or x and y axis. So -1 is the horizontal component. So that's -1 to the left, and I should have planned ahead because it's going to not fit well on my paper here. So I'm going to make this my initial point. -1 is 1 unit or 1 space to the left, and then 4 is the vertical component. That's 4 units up. So then the vector would look like this, where the terminal point is right here. So here's the horizontal component, -1. Vertical component is +4. That's basics of vectors. And then similar to naming rays, you can name a vector as well if the specific initial point and terminal point are named. So let me call this point A, that's the initial point. Point B is the terminal point. And then the name of the vector is vector AB. Okay, be very careful here, like you always should be. So that's actually the length of vector AB or the magnitude of vector AB. And then even though I made an arrow here for the vector, I'm actually not going to make a full arrow here to write it in vector form. The first letter has to be, or the first point has to be the initial point. Second point has to be the terminal point. You basically make half an arrow. So it would look more like this to draw. I actually wouldn't put an arrow part right down here, but that's how you name a vector. Similar to how you name array, but not with a full arrow at the end.